All right, Newton's second law of motion. So, Newton was actually the one who discovered the idea of force. He noticed that force is proportional to the acceleration of an object. So, meaning, if you apply more force to an object, the more it's going to accelerate. He also found that force is proportional to the mass of an object. So, the more mass an object has, the more force that is going to be needed to actually move that object. Moving objects accelerate when an unbalanced force acts on them. The stronger the force, the greater the acceleration. But also, the greater the mass of that object, the greater the force required to change the motion. So there's actually an equation that goes with this law. Force is equal to the mass of an object times its acceleration. F equals m times a. So when we say that force is measured in newtons, that's because force is equal to the mass, and remember mass is in kilograms, times the acceleration, which is meters per second squared. So we are going to be using this equation, F equals ma, quite a bit. So go ahead and get used to seeing this equation and go ahead and just memorize it. F equals ma. Force equals mass times acceleration. All right, so just a reminder, a force is a vector, which means it has both magnitude and direction. So, as we go through this lesson, when we talk about unbalanced forces and forces in general, the direction of that unbalanced force is the same direction of the acceleration. So that means if you have some sort of object, and let's say that you have one force going to the right, and as you can see, it's a huge force. Maybe it's 20 newtons. And then you have just a little bitty force on the other side. Maybe it's 5 newtons. So clearly, this is unbalanced forces. And clearly, the object's going to end up moving to the right because this force is huge. So the direction of this winning force to the right means that that object is going to accelerate to the right. All right, let's talk about mass and weight. So mass is the amount of matter that an object possesses. I think everyone knows that definition by now. Mass does not change with location. And what I mean by that is your mass does not change. If you were hypothetically going to travel from the Earth to the Moon to Jupiter to Mars back to Earth, your mass would be the same number value in every single location that you travel to. However, weight is the gravitational force that a large body, such as a planet, exerts on another object. So we only have weight because gravity pulls us towards the center of the Earth. However, but if we went to a different planet, Mars or Jupiter, our weight would be different. So weight is a force. It is measured in newtons. So I know that everyone's used to saying like, oh, I weigh 100 pounds. Yes and no. That's fine to say that, but however, just know in physics class, weight is going to be measured in newtons. And remember, newtons is a big capital N. So to calculate your weight, if you wanted to find your weight, you could calculate your mass. And remember, mass is in kilograms. Times the acceleration due to gravity. So on Earth, our acceleration due to gravity would be 9.8 meters per second squared. So the reason why we can calculate this is from Newton's second law of motion. So remember Newton's second law of motion, we just said that the equation is F equals m times a. And really, that equation just says that you can calculate a force as long as you have the mass and the acceleration of its movement, or just with gravity. You can have acceleration due to gravity. So the force that we're focusing on is weight, and you can find the force of weight, which is equal to the mass times the gravity of whatever planet you're on. So for Earth, it's always going to be 9.8. So remember, weight does change with location. So because weight is the measure of mass times gravity, it will change because gravity changes whenever you change location. the gravity from the Earth to the Moon to Jupiter to Mars, none of the gravities are the same. So that means that on every single planet and moon that you travel to, your weight would be different on every single place that you travel to. So weight changes, but your mass would be the exact same no matter what. All right, so before we get off, I would like to say that my way to remember that Newton's second law has an equation is that if you hold up two fingers, turn them sideways, kind of looks like an equal sign, right? Newton's second law is based on an equation. Force equals mass times acceleration. So that's just my way to remember that Newton's second law is this equation. If you can come up with something else, please leave it in the comment. I'd love to hear some other suggestions. Thanks for watching.